Good morning, everyone. Happy Monday.
Not really. I wouldn't say it's not even as big as
You saying something?
basketball. I don't even think it was. It's probably about that size.
You saying something to us? All right. Good morning, everyone. Happy Monday. I'm not sure how your weekend was. Mine was pretty rough. I was out of power until yesterday night, since Friday night. So I did not have power on Friday night, Saturday, Sunday, and finally it came back yesterday evening. So your homework was extended on Friday itself. So I'm glad I extended it right after the class for everybody. So your homework 2.5 to 2.7 is due tonight, and your quiz was also extended. So it's due tomorrow. I think they were due on Saturday and Sunday, but I extended. So make sure you work on that. And again, we will have one more class on Wednesday before your test one. So if you have any questions on that, feel free to ask. We are going to do the test review for chapter one today, since we have only two chapters. So let me just quickly tell what the format and all. So your test one will be on Friday, as mentioned in your schedule, which is February 19th. As I mentioned earlier, we were planning to have this test on campus, but now it will be online because we are continuing our classes through Zoom as we did in first 4 weeks until further notice. So your test will be on Launchpad. And the format of the test will be same as your homework and quiz. And let me see. My computer is not good, but I'll see if I can record this session. So before I start recording, if your Zoom camera is on with the this privacy policy, I cannot send this recording to all of you if your cameras are on. So if you think you guys want this recording, make sure that your cameras are off. So let me see. Anyone has any questions?
Someone in the chat asked if the test is open until 11:59 on Friday.
No. I will talk about it. Okay. Because the test has specific time window, so it will not be open for the whole day. But I'll talk. That's why I'm thinking if it will be better if I can record it. Well, it's not giving me that option. So let me see. And let me share this again. I'm not sure if it's recording or not though. right. So your test one will be on Friday, February the 2nd, 19th. I'm sorry. Your test will be on February 19th, and which is a Friday. And your test will be on Launchpad. The format of the test will be same as your homework and quiz. And when I say mentioned as homework and quiz, that means you will get the test on Launchpad. And then when you see test one on Launchpad, you will open it the same way how you open your quiz and homework. And I will say that it will be in the quiz format because it is timed. And the total time is 50 minutes, which is our class time. And as someone asked, the test will be open the whole day. Test will not be open the whole day since we were planning to have the test on campus in person. So it will be during the allotted time from 11 to 11:50. But I'm thinking of giving you some extra time before and after. So the test window will open from 10 to 1 p.m. So you have a 3-hour window, and in that 3-hour window, you can take the test. And again, we have a class on Friday. So instead of class, you can take that test during that time. But if you think that you need more time or you want to do it before, you can start your test as early as 10:01 a.m. And then first 50 minutes, and it will be closed in 50 minutes, no matter you start at 10, 12, 12:30. And again, if you start later, like 12:30, 12:40, 12:50, no matter what time you start, it will stop at 1 p.m. So make sure that when you start, you have 50 minutes in your hand. So your test window will be 3 hours. Instead of just giving that 50 minutes, I thought, or me and Miss Minion decided to keep the window 1 hour before and 1 hour after the class so that you can take this test according to your time schedule. Any questions about time window or the format of the test? So everybody good with this part?
Yes.
Thank you. So your test will be on Friday, and test will be on chapter 1 and chapter 2. There will be 20 to 25 questions, multiple choice. So there will not be more than 25 questions. The max you can have 25, and minimum you will have 20. So 20 to 25 questions will be in your test from chapter 1 and 2. And the test is multiple choice, same as your homework and quiz. So this is about the format of the test, the test window, and what chapters are included. So let's start the review for chapter 1. So for what we learned in chapter 1, and then there are few topics that I'm not covering in the test, so I'll talk about that also, so that you were tested on homework and quizzes, but you may not be tested on those concepts in your test. So I'll talk about that also. So chapter 1, first we talk about individuals and variables. So you need to know the difference between individuals and variables. When we say individual, we say the objects of interest, and variables are the characteristics of those individuals. And we also talk about types of variables. We talk about categorical and numerical. So make sure you need to know which one is categorical and which one is numerical variable. So basically you need to identify individuals and variables. If there are variables, what kind of variables you are working with, categorical or numerical. And once you know what kind of variable you are working with, you need to know how to graph those. And once you know their graphical representation, then how to read those graphs. So first, identify individual variables, and there are questions like very similar like you have in your homework and quiz. Is it a categorical variable, or is it a numerical variable, or is it a categorical variable? Then what kind of graphical representation you do for this categorical variable? Is pie chart a good representation? Is bar graph a good representation? Or if it's a numerical variable, will you make a bar graph or you make a histogram? And if you make a bar graph, is it the right way to represent a numerical variable? Or is histogram a right way to make a categorical or represent a categorical variable? What is the difference between a bar graph and histogram? Which one is used to which kind of variable? So we know that when we talk about categorical variable, the graphical representation is either a pie chart and bar graph. When to make pie chart and when to make bar graph. When you add up all the category percentages and they add up to 100%, we talk about pie chart. Bar graph, when you are representing individual category in a form of a graph, you can use bar graph. Again, when we talk about pie chart, you make or you define categories using different slices, and then you need to know how much is that as a whole, or how much this category as a whole, or this, or this, or this, by looking at the percentage of this with the whole, or this with the whole, or how much is the percentage of these two categories comparatively to the whole. So you need to know the percentage of this, you need to know the proportional percentage of this, and then you add. Same thing when you talk about the bar graph. Why I'm making a bar graph for this particular category? Why not a histogram? And we know that histogram talks about the interval of equal length, while when we are talking about categorical variable, we do not work with numbers, we work with categories. So we are using bar graph instead of histogram. Once you know the categorical variable, and when you start working with numerical, what are the graphical representation? First, you look at the histogram, or you can make a stem plot, box plot, and time plot. So you will not be tested on time plot because we did not work too much on time plot. We just talk about how the time plot is and why do we use time plot. Though you have a question in your homework assignment or quiz on time plot, so you know time plot, but again, you will not be tested on time plot or quantile plots. So these two parts you will not be tested. So you need to know what a histogram is, what a stem plot is, what a box plot is. So when we are talking about a histogram, again, histogram help us to see the shape of the distribution. Histogram, if the shape is skewed, then or if the shape is symmetric, it will help us to see if there is a relationship between mean and median and what kind of relationship they have. And same thing, stem plots are rough histogram. It also helps us to see the shape of the distribution. It also helps us to compare two separate data set, or you can make side-by-side stem plot to see how two distributions are similar or how two are different. When we are talking about box plot, we use 5-number summary, and this 5-number summary help us to see or to make a box plot. Again, when we talk about 5-number summary, we use median as the center. So when we are talking about box plot, we are working with median as the center. And when we are saying we are taking median as the center, that means we are working with a skewed distribution. And when we work with the skewed distribution, we can see if the distribution is more skewed to the left or more skewed to the right to see if it is right skewed or left skewed. So when we are talking about the shape of the distribution and looking at mean and median relationship, or you can say when you look at the overall pattern of a stem plot or a histogram, what two things you see? First, you look at the shape, center, spread, and outlier. And we covered all these topics in chapter 1. So I'm just going over those. So shape, either symmetric or non-symmetric. Center, if you are taking a symmetric distribution, your center is mean. Non-symmetric, it's median. When it's mean as the center, then you work with standard deviation as your spread for the deviations around the mean. And here you work with quartiles. And then outlier is something outside your overall pattern. So once you have only, let's say, if we are looking at the overall pattern of a histogram or a stem plot, but I don't have a histogram and stem plot, but I have only mean and median. How do I decide what kind of distribution I'm working with? Then I look at the relationship between mean and median. So you look, how are mean and median related? Are they same? Is mean greater or is mean less? So either they are equal or they are not equal. If they are not equal, then one is greater or one is less. If it is equal, then we say that we are talking about symmetric distribution. In symmetric distribution, both mean and median are same. For non-symmetric distribution, either the mean is bigger or the median is bigger. Either one can be bigger or either one can be smaller. So how do we see what kind of skewness we see when mean is greater or mean is less? Mean always follows the tail of the distribution. So if we are looking at the distribution and let's say we are looking for this one, mean is always going in the direction where the tail of the distribution is going. So farther the tail is, the farther the mean is. And when we say farther the mean is, both mean and median talks about the center. So median is the center, so half the observation here, half here. And mean is the balancing point, so where it is balancing. So mean is on the right side because the tail is going here. So mean is greater than your median. And when the mean is greater than your median, you have skewness going more towards the right. The bigger the mean, the higher the tail is on the right side. So you can say when mean is greater, you see right skew. And same thing, when mean is smaller, the skewness is towards the left side. It's close to 0, so it's left skewed. Sometimes you have to take the decision only on the basis of mean and median, but sometimes you have to look at a histogram and also take that decision. So if I'm looking at these two histograms, what can we say about the shape of the first histogram and the shape of the second histogram? So if I see here, I can see it's like this, and for this I can see here. So just looking at the histogram, I know that this is skewed towards the right side. So I can say right skew distribution, and this looks like roughly symmetric distribution. But they both have single peak, and here, if I'm saying it's roughly symmetric, that means it's dividing into equal halves on the left hand side and the right hand side, and both mean and median are roughly same. So again, you need to know how to read these graphical representation of both numerical and categorical variable. And there are questions in the test where you have to read these graphical graphs, and then you need to talk about either the shape of the distribution or the relationship between the mean and median, or why do we use this representation over this. So there are at least 2 questions or maybe 3 on this topic. So make sure you understand this very well, how to read, how to find the percentages, either using the histogram or using the pie chart. Where is my median, in which interval? And for that, I can suggest you to look at Stat 108. If you look at 1A notes, this is exactly what I just talked about. We talk about individual variables, we talk about categorical, we talk about quantitative variable, and then we also talk about their pie chart, graphical representation. What is pie chart? What is bar graph? When do we use pie chart? When do we use bar graph? Same thing, how to make a histogram or stem plot or box plot. And again, you will not be tested on time plot and quantile plot. And shape, center, spread, and outlier, we also discuss what's the difference between bar graph versus histogram. So you do not need to worry about this topic. So I will suggest you to go over these concept check questions, and and you have very similar question in your homework and quiz. So here again, it's talking about how many individuals are there, how many variables, what kind of variable you are working with, how do you represent that variable. Similarly, you have a bar graph. If you are using this bar graph to find the percentage of this category, how do you find? You just look at this and then divide with the total, and total is this plus this plus this plus, and then you can find that the proportion or the percentage of particular category, or if you are looking for these 2 categories, so find this separately, this separately. Do not add these 2 and then divide. First find the percentage of this separately and this separately, and then add. Or if you are looking for only these 2, or on the right of this, left of this, once you understand how to find it, then you can do it whatever the question is asking. If it's asking you only the data service, then you can just look for this 30 divided with the sum of all, and I know how much is 120. Similarly, if I'm looking for data service and church, then I can add this plus this, divide. So percentage of this, and then you can do that. Same thing, if you are looking for the pie chart, you can make a pie chart if all these category percentages added up to 100%, and then you calculate it for each. And if again I'm looking for this one, how many I have data services, I have 30. So 30 divided by 120, and I can get the percentage of this, and then you can find the percentages of all. Stem plot is also given to you here. And again, when the data is given to you, make sure whenever you work with the data set, try making a habit of organizing your data set first. Again, when you are solving just for mean, even if you organize or you do not organize, it's not going to change anything, because you add everything and then you divide with the total. But if you are working with median, then it can mess up your results, because when you are working with the median talks about the center of minimum and maximum. So first you need to arrange your data set. And when you arrange your data set, it will be easier to locate your median. And then you can locate or you can find your quartiles, Q1 and Q3. And stem plot is an easy way to work with. When you work with stem plot, first of all, it will give you, stem plot is a rough histogram. It will give you the shape of the distribution easily. You can see what is the shape of the distribution here. And then it can also tell us how many observations in each stem and where exactly those are and how many are empty. So stem plot are basically rough histogram and easy to read. It also helps us to find the median and quartiles, and using that we can make a 5-number summary, and we can also make a box plot using that 5-number summary. And stem plots are easy also in the way if you are working with two. Here, let me say. So in this example, it says that make a stem. There are 210 roster of Pittsburgh Steelers professional football team included 7 defensive linemen and 9 offensive linemen, and the weight in pounds are given. So you have 2 data sets given, and you can compare those 2 data sets side by side, making the same stem, and then leave on. This is, you say defensive and here offensive, and you can say that these 2 distributions are little different in shape, or they are same, or where their median is, what their minimum is, what their maximum is. Their minimum is 280 and their minimum is 34, and their maximum is 280, not 34, 304. And there is 325 is the maximum, while there is 343. So you can say how their minimum and maximum are different. What about their range? What about their interquartile range? So you can compare side by side. And in the stem plot, the leaf units are, if the leaf units are not given, we take it as 1. But if the leaf units are given, we read that, let's say it's 230, but each leaf is 100 units. So it's 230 times 100. So it's 23,000. And similarly, if the question is asking what is the actual value related to the stem 28 and leaf 7, so 28 and 7, I can say 287 times my 100, so 2,800 to 28,700. And similarly, take a look at those, and this is what exactly I mentioned. If you look at the stem histogram, how do you read those histograms? So you can say that this histogram is right skewed. It has 1 peak and the center around. And again, how do you find the center? You look at the number of observation, then you go to the median, because you are talking about right skewed distribution. If you are saying right skewed, that means we work with the median as the center, not the mean. And when you work at the median, then find the median. And then similarly, you can see if there are outliers, no outliers. So you can read a histogram with the information that you learn. Is it is it unimodal? Is it bimodal? What should be the area under the curve? So you can do all that information. And you will not be tested on this. All right, so this is one part, and the next is how to find the outliers in your data set. Questions so far? Outliers. So when we are talking about outliers, so that means that is lying something outside your overall pattern. You can detect the suspected outliers in your data set by using 1.5 IQR rule. And what 1.5 IQR rule talks about, that means first you need to find the interquartile range, and what that range is, we work with 5-number summary. We look at minimum and maximum. Once we know what our minimum and what our maximum is, we can find our median, and which is my Q2. And once we find our median, we can find another median, or you can say left median and right median, and that gives me my 5-number summary. I can use this 5-number to make my box plot. And if I have suspected outliers, I can use this rule to see if there are suspected outliers in my data set, and then plot those suspected outliers in my box plot. So how to find the suspected outlier? First, you find the range, and range is the difference between maximum and minimum. So range means highest minus your lowest. That will give you the range. When we are talking about interquartile range, so that means we are talking about the quartiles. And the quartiles, 2 quartiles that I have above and below the median, are my quartile 3 and quartile 1. And definitely Q3 is closer to maximum and Q1 is closer to minimum. My Q3 will be bigger than Q1. So I subtract Q1 from Q3, and that will give me my interquartile range. Range between 2 quartiles. Range inside the 2 quartiles, I'm talking about interquartile range. So if there are questions in your exam asking you find the range, then look for this. And again, if you're looking for minimum and maximum, first thing is arrange your data set. If the data set is not organized, your range will be not correct. If your range is not correct, your median may or may not be correct, and that will again mess up your quartiles also, and which will mess up your interquartile range. And we need interquartile range to find the suspected outlier. If IQR is not correctly calculated, it will not give me the correct interquartile range, which I need to use to calculate my suspected outlier. How to calculate your suspected outlier? You look for Q1, and again, your Q1 should be calculated correctly. Then multiply your interquartile range that you calculated here with 1.5, and then you get some answer. And then look the higher quartile and add this, and you will get some answer. So anything outside this range, so now let's say I'm just taking some number, let's say I get 40 and 260. So anything below, and I'm just talking about this particular example, below 40 and above 260, and it depends what number you get when you calculate this. But in this example, we are taking, let's say we calculated, and my Q1 minus 1.5 IQR comes out to be 40, another comes out to be 260. So anything lower than 40 or anything higher than 260 is a suspected outlier. And then you can make a box plot using 5-number summary, and you can make box plot either horizontally or vertically. So you make a box using Q1 and Q3, and then find where your median is. And then since we start from here, so minimum is on this side and maximum is on this side. And once you calculated your outlier, anything above this range, and once you know what your outlier is, then you can denote your outlier using this or this, depending how many you have. And then that's how you make a box plot. Again, you will not be tested on how to find the outlier or how to graph the outliers on your box plot. You will not be asked to make the box plot manually and find and represent your suspected outlier, but you need to know how to read the box plot, and if there are outliers, how many after looking at this range. So you should be good reading that, but again, you will not be asked to plot or make a box plot. So this is about 5-number summary. And the last topic that we have in chapter 1 is density curves. And again, there are a lot of topics or a lot of concepts in both chapter 1 and 2. And your test is 50 minutes. So I cannot test you on every single topic in this chapter. So do not say that in the review you talk about everything, but there were only 5 questions on those topics. So I'm telling you what topic is you will not be tested, but I cannot skim down that these are the 5 topics that you get questions on. I'm trying to explain you all the concept or all the important concept, but there will not be question on every single concept. Until unless you want, I can make the test longer and we can open it for longer duration. Instead of 50 minutes, we can do 1 hour, 15 minutes or 20.
No, thank you.
Okay. So when we say density curve, what are density curves? So you need to know, and again, it is important concept. When you are talking about density curve, you know what actually a density curve means. So the definition of density curve is important. Again, you have questions in your homework and quiz on that as well. So density curve, what are density curve? They are on and above the horizontal axis. And we know that area under the curve is always 1 or 100%. And what is area means? So area under the density curve, when we are talking about area under this density curve, what does this area means? It means that area under this density curve above any range of values is the proportion of observations. Proportion of all the observations that falls in this range. So what does we say that area under the curve is 1 whole or 100%. So basically how many or the proportion of all the observation that falls in this particular range from here to here, and it starts from negative infinity, goes up to positive infinity. And when we are saying density curves can be either symmetric or non-symmetric. Not necessary that they are always symmetric. And we learned that they are skewed also. So they can have many shapes. They can be either symmetric, they can either be non-symmetric. We also learned that unimodal, we say bimodal, and we also talk about multimodal. So not necessary that they are only single peak. They can be multi-peak, they can be bimodal. Again, when we are talking about density curve, and when we say normal density curve. When we are using this normal density curve, then we are saying that it's single peak symmetric density curve. Single peak symmetric, and then bell-shaped. So again, when we are talking about density curve have many shapes. They can have many modes. Not necessarily they have just one peak or one mode. But when we talk about specifically to normal density curve, then normal density curves should satisfy these 3 properties. It should be single peak, unimodal, symmetric, and then bell-shaped distribution. We denote normal density curve with using this, where mu is your mean, and sigma is your standard deviation. And I forgot to talk about sigma in the earlier, where we are talking about the overall pattern. Sigma is standard deviation. So let me just quickly go on that. When we are talking about standard deviation, we are talking about how many deviations away from the mean, either in the left direction or in the right direction. If this is my mean, and I'm moving left and right to the mean, then how many deviations from here to here, or here to here, or here to here? Then we are talking about standard deviation. In simple word, we can say that standard deviation measures the spread around the mean, or it's the distance around the mean, either to the left of the mean or to the right of the mean. So the property of standard deviation is it is always greater than equal to 0. So it is always greater than equal to 0 means it is always positive. It can never be negative. It cannot be negative. And why not negative? Because we say that spread or the distance cannot be negative. It can be in left or right direction of the mean, but it will not be negative. And when we say standard deviation is equal to 0 and standard deviation is greater than 0, so this is the property that distance is always greater than 0. Under what case the distance equals 0? The distance is equal to 0 when all your observations, all your xi's are same. And what do we mean same? That means if all the observations are same, let's say this is my x1, x2, x3, x4, 5, and when I look at the mean, I get the same mean. And when I have mean as 6, how far this observation away from mean? This. They're all at the same point. So your standard deviation is 0 in that particular case. Again, you know how to find the standard deviation. We have a big formula, and then you also have a calculator, and you know how to use your calculator to solve for standard deviation. So make sure that you know how to calculate your standard deviation or the properties of the standard deviation, how standard deviation help us to see the shape of the distribution, because we are using the standard deviation here when we talk about density curve, when we talk about normal density curve or standard normal density curve, or when we look at the area under the curve or z, then we use this. So if we know how to calculate, well, good. If we do not, make sure you know how to calculate. But if it is given to you straightforward, what does that mean? So it tells you how far that observation or how far each deviation around the mean. So standard deviation goes with the mean when mean is your center. So come back to normal distribution. When we say we are talking about normal distribution, normal distribution is defined using two things. One is the mean and one is the standard deviation. So when we talk about normal distribution, these three properties should be there. You satisfy these three properties, and then you need to know one more thing. When we are talking about normal distribution, we can standardize this normal distribution to find the area under the curve. And how do we standardize? We use mean as 0 and standard deviation as 1. And once we standardize, then we can use this standard normal or standard normal table to find the area or the proportion of observation under the normal density curve. And that's why we standardize. We keep our mean as 0 and standard deviation is 1. And then you can simply keep on going depending upon how many standard deviation you are working with. Once you know you're working with normal distribution, you can find the area under the curve, under the normal density curve. And again, this rule is applicable only when we are talking about normal density by using 68, 95, and 99.7% rule. And this rule tells us that there are 68% area or 68% of observations or proportion of observations lie in one standard deviation to the right and left of the mean. Here, within 2 standard deviation to the left and right of the mean, and here within 3 standard deviation left and right of the mean. So if you have a question, in general, I'm saying, first see if you can apply your 68, 95, 99.7% rule if you're working with normal distribution and knowing what your mean and what your standard deviation is. We normally work with 95%, and we roughly say that 95% is within 2 standard deviation to the right and left of the mean. And we are saying approximate. It's not exactly 2 standard deviation. It's not exactly 1, not exactly 3, but they are approximate 3 within 1 standard deviation is approximately 68%. Within 2 standard deviation, approximately 95, and this. And we will learn in later chapters that when we talk about 95%, the actual is 1.96, but we take roughly as 2, and similarly for this also. But right now we can work with 68, 95, and 99.7% rule. That is the first thing that we apply when we work with normal distribution. And again, when we are talking about normal distribution, we standardize, and we can use table A to find the area under the curve. Again, table A is one of the options. So make sure if you're using table A in your exam, keep that table A handy. Either you can open another tab where your table A is there, or keep a printed version, because there will be questions in the test where you can either use table or use your calculator. So make sure if you are thinking of using table A, since we are not having the exam on in class or in person, so make sure you have the tables handy so that you can use those, because Launchpad will not provide you any table along with the exam. Or you can use calculator. And again, when you are using calculator, make sure that your calculator has enough batteries and it will be it is in the working condition. So you can use either table A to find the area under the curve, or you can use calculator. We talk about both options. Table A, again, you go to table A to find the corresponding value of Z, and then you can look for the Z, and we learn how to find a value in the table. You can use your slides also. It is mentioned in the slide also how to use table. And at some point, if you have a question, feel free to ask any of us how to use the table. You can use calculator. Again, you can use calculator if you are using the area under the curve using normal CDF. If you are finding the area, you need to know the area of what. So you need the bound to find the area. What is your lower and what is your upper? So I'm looking at the area between this range. So here you will write your lower limit, then you write your upper limit, and then specify your mean and standard deviation that is provided to you in the question, and then you can find the area under the curve. If you're using 68, 95, 99.7, use this. If you're using something, if this rule is not applicable, again, this rule is only applicable when you're talking about normal density curve. If this rule is not applicable in the sense if you're talking about 94%, or if you're looking for something else, then you use your calculator. And then if the area is provided, here you are finding the area, either using this or this. If the area is provided, how to use the calculator or table? Again, convert your area into decimals. And find your left-sided area first. Because the table gives us the left-sided area, and the calculator also use left-sided area. So find the left-sided area first. Once you find the left-sided area, go to the table and find your corresponding Z value. And again, when you use the table, you will not get the exact Z value. You will get the closest Z value to the area that is given to you. Once you find that, then you can plug that in this formula that we use for standardizing score, and it will be Z sigma. And if you're solving for X, these two things are given to you in the question. You calculated this, and then you are done. In your slide, there are questions. In your Stat 108 note, there are some questions solved. But if you're using the calculator, use inverse normal. And when you use inverse normal, it asks you to find the area, plug the area, mean and standard deviation, and area to the left. And it will give you your corresponding X value. If you are looking for the corresponding Z value, make sure you keep mu as 0 and standard deviation as 1 if you are looking for Z, because you are looking for Z using standard normal or standardized. So standardized you have N, 0, and 1. And that's all for your chapter 1. So I will stop here, but if you have any questions, let us know. And then we will talk about chapter 2 in the next review session. Thank you, everyone. Have a wonderful day.
Thank you.
Thank you.
Thank you. And if this recording comes out fine, then I will upload that on your Canvas.
Hello, Monica.
Hey, Minion.
How's everything?
Huh?
How's everything?
Oh, finally, the power is back. So ready to get back on track. So Dr. Gupta does not have power either. They also got their power last week. Yeah. So let's see. Yeah. So I think, as mentioned, you don't have to attend my office hours because I am going to see some other students from other class. I'm not sure if this class, but I have a couple of students. They want to see me, so I said, okay, this is the time. So.
Okay. Alrighty.
And I will log in back in 10 minutes because it's the class.
All right. I'll see you.
See you at 1
later.
One o'clock.
Yes.
Yeah.
All right. Bye.